Okay, Assalamualaikum and good morning, everyone.
Good morning.
Okay, so today I want to discuss some of the tutorial question before we proceed with discussing about the concept of stress. Okay, before continuing with lecture number 2 that we stopped last week. So I hope that you have done the tutorial, and maybe if you have done it, then you understand some of the procedure or the process to determine the reaction forces at certain reaction point. And then if you continue further with the tutorial, you also understand the process to determine the internal loadings in the respective points. For example, in the question, all of the questions wanted you to find the loading at point C. Okay, so we look at some of the example. Maybe we can start with example number 1, F11. Okay, then maybe example F12, then maybe the last one F16. Okay, so let's look at example F11. So in this example, you are given a 60 kilonewton meter moment at one end of the beam, and then another load or force 10 kilonewton acting downwards at another end of the beam. We have 2 points of contact at point A with roller reaction or roller contact, and point B pin support at point B. And the question asks you to determine the internal load, internal force, normal force, shear force, and also bending moment at point C. So as I said last week, the first step that you need to do is to find or to determine the reaction forces at point A and point B, or at the reaction points, before you can determine the internal force or internal loading at the point C. So here, from here, you need to determine reaction forces at A and also reaction forces at point B. So let's look at how we can do this. Okay. All right. So we can draw the free body diagram. And then for the free body diagram, you need to remove all of the support in the beam and replace it with the reaction forces. So here we have 60 kilonewton meter at one end of the beam, and then we have 10 kilonewton at another end. And then we have point A here. So here at point A we have we can we can split the reaction force into x direction and y direction. So we have AY and also AX. So point A is 2 meter from the end of the beam. And then at point B, we can also okay, sorry, there is no AX for point A because it's a roller beam. So roller support. So roller support has no AX direction. Okay, sorry. So we only have AY. And at point B, we have pin support. So we have BY and also BX. And it is 2 meter from the other end. So we have point C in the middle. All right, so this is our free body diagram. Okay, so basically free body diagram, you draw all of the forces and remove all of the reaction support, all of the support. Okay, and replace it with forces. Now, when you have the all of the forces drawn on the free body diagram, then we can determine the unknowns, which is AY, BX, and BY. So maybe we can start with usually in the answer, okay, in the answer from book example or from the solution manual, they will try to solve moment, okay, equilibrium of moment first. So here you can determine the equilibrium of moment at point B. So why point B? Because at point B you have BX and BY. So by finding moment at point B, basically you eliminate BX and BY in the equations, okay? Meaning that in your equation there will be no BX and BY. So let's try moment at B and see what I mean by removing the forces. Okay, so moment at B, summation of moment at B, assuming counterclockwise positive. So firstly, we have the force 10 kilonewton times 2 meter, and this moment is rotating counterclockwise. Okay, so 10 kilonewton times 2 meter, the direction is counterclockwise. Okay, so we have 10 times 2 positive. Oh, clockwise, sorry, clockwise, negative. And then we have the force AY. So force AY times 2 meter from point B. So we get clockwise direction. So again, we have negative AY times 2. And then lastly, we have 60 kilonewton meter. So this is already a moment. So you don't have to multiply with distance, okay? So you just take the direction of the moment, which is in the question, it shows counterclockwise. So counterclockwise is positive. So you just add 60, okay? It's positive already. So equals 0. Then here you can solve for AY equals 60 plus 20 divided by 2. No, sorry, 60 minus 20. 60 minus 20 divided by 2, negative. So you get okay. So you get AY equals 20 kilonewton. Okay. So you get AY already. Now you can determine the other two forces, BX and BY. So maybe we can start with uh, Bx or force in the horizontal direction. So in horizontal direction, we only have Bx, okay, Bx, and there are no other forces in horizontal direction, so Bx equals 0. Then now we can determine using equilibrium for forces in vertical direction. So for vertical direction, you have Ay going up and By going up. So plus By, Ay plus By. And then we have 10 kilonewton going down. So minus 10 equals 0. So we already have Ay. So we can determine By equals 10 minus Ay, or simply negative 10 kilonewton. Okay, so here you already determine all of the reaction forces Ay, Bx, and By. Now you can substitute all of these forces back into the beam, and then like Wei Jin said last week, kita potong ya, kita potong the beam at point C. Okay? Now we can cut at point C. So here we can redraw the free body diagram. Okay. So now we cut at point C. So when we cut, we can draw all of the forces and moment at the internal loadings at point C. So here we have NC. NC meaning that the force that acts the normal force at point C. And then we have VC going down, or the shear force at point C. And also we have the moment at point C. Okay, we can draw the other points like point A. And also the moment here, 60 kilonewton. Now again, you want to determine NC, VC, and VC, the internal loading at point C. So again, you apply the equilibrium equation of equilibrium to determine NC, VC, and MC. So firstly, maybe you can use force in the x direction. So in the x direction, you only have NC. So NC equals 0. And then we can use the vertical direction, the y direction. So here we have AY, we have BC minus, and that's it. Okay, there is no other vertical forces. So you get VC equals AY, or equals 20 kilonewton. And then lastly, we can determine the moment at point C. Okay, so at point C, we already have the internal moment, MC. And then we have AY times 1 meter from point C. And this acts clockwise. So we minus AY times 1. And then we have the 60 kilonewton moment here, which is in counterclockwise direction. Okay, so plus 60 equals 0. So MC equals AY minus 60. So we get negative 40 kilonewton meter. Or we can say this is 40 kilonewton meter clockwise. Okay, so that's it for question 1. Anything that you want to ask?
Dia kalau negatif tu maksud dia clockwise ke doktor?
Sorry, tak dengar sangat.
Dia kalau apa 40 negatif negatif 40 kilonewton meter tu, dia kalau negatif dia jadi clockwise ke macam mana?
Dia clockwise sebab in the free body diagram kita define dia counterclockwise. So counterclockwise kita define sebagai positif. So kalau dapat negatif dia jadi clockwise lah sebenarnya. Okey tak?
Okey doktor.
So you can either say negative 40 kilonewton, 40 kilonewton meter ataupun 40 kilonewton meter clockwise. So contohnya MC ni you define dalam figure, let's say you define dalam figure macam ni, meaning that clockwise. So in the end you akan dapat positif lah, positif 40 kilonewton clockwise. So macam saya ajar dulu dekat student BFF dengan BFM, saya suruh diorang tulis the direction like either clockwise or counterclockwise in case some of you dapat positif lah, dapat negatif. Tapi in the end if you draw your free body diagram and then you show in your free body diagram the direction correctly, contohnya macam soalan ni MC counterclockwise, you draw the direction and then in your calculation pun you guna correctly, okay? MC positif sebab you define counterclockwise positif. Tak kisahlah jawapan akhir apa, yang penting kita tahulah kalau negatif it's clockwise based on your definition. Tapi kalau you define let's say kat sini counterclockwise, you define positif, tapi you lukis sini counterclockwise, tiba-tiba you letak sini negatif, for example, mana yang sini salah lah. Kita tolak lah satu markah ke, tolak lah dua markah ke, macam tu lah. So make sure when you define in your calculation, you use it correctly. Okay, you use the direction correctly in terms of positive, negative. Okay. Okay, so kalau okay, kita tengok soalan yang kedua pula. Okay, so for second question, determine the internal normal force, shear force and bending moment at point C. So the same thing, find the internal loadings at point C. But now you have distributed load, okay? You have distributed load 100 Newton per meter at one side of the beam, and on another side it's 200 Newton per meter. So the same rules, you need to determine the reaction forces at point A and point B. Draw the free body diagram, determine the reaction forces, and then you potong dekat point C, okay? You potong macam Wei Jin cakap, potong. Okay, so let's try do this question. Okay. Okay, so firstly, you need to draw the free body diagram. And then mark the points. So point C, we have point A over here. So point A is pin support. So look again, point A is pin. So this is roller. So for pin support, you must have AX and AY. So for roller, you only have the direction that the beam is attached on the point, the support. Okay, so for example, let's say if you have vertical beam and you have a roller support here, so you only have y direction. Okay, so here you have only have vertical direction by. So this is bx, silap. Okay, so this is bx, so this is by. Okay, but for pin support you must have both direction ax and ay. Okay, so let's redraw the free body diagram. So here at point A you have ay and ax, and at point B you have by, and they are 1.5 meter from point C. And then we have two distributed loads on the beam. So the first half is 100 Newton per meter. 100 Newton per meter. And the other half is 200 Newton per meter. So for the 100 Newton per meter, you must transform the distributed load into a single load, okay? A single resultant load. So here you have 100 times 1.5. So just multiply with the length. And then it is acting in the middle of the beam, okay? So it will be 0.75 meter. And then the other distributed load, 200 times 1.5, and similar, it will be acting in the middle, okay, 0.75. Okay, so this is the free body diagram. You remove all of the support from the from the diagram and replace it with forces. So that's the meaning of free body diagram. So after you draw this, then you can determine the value ax, ay, and by. So firstly, maybe we can use moment. Okay, so we can find moment at point A. Okay, counterclockwise positive. So at point A, so we have 100 times 1.5 times the distance 0.75, and this force will have a moment in clockwise direction. Okay, negative 100 times 1.5 times 0.75. And then another moment is the 200 times 1.5, and now it must multiply with the distance 1.5 plus 0.75, and it will act in clockwise direction, meaning negative. So we have negative 200 times 1.5 and times 1.5 plus 0.75. Okay, times the distance. And then lastly, the force By. So By times the distance 1.5 plus 1.5, and it will be in counterclockwise direction. So it's positive By times 1.5 plus 1.5 equals 0. Okay, then you can calculate. So 3By minus, so let me calculate with my calculator. So minus 112.5 minus 675 equals 0. So By equals macam salah je. Oh my god. Okay, so By equals 262.5 Newton. Okay, now we can proceed with the equilibrium of forces. So maybe we can start
Doktor,
with ni saya.
nak tanya 3 BY tu dapat dari mana?
Ni 1.5 tambah 1.5.
Oh,
Okay.
okay.
Alright, so we can do force in the x direction. So in the x direction, we only have ax. There is nothing else. So ax equals 0. Then we can do force in the y direction. So here we have ay plus by. We have the loadings 100 times 1.5 going down. So we have 100 times 1.5 and also 200 times 1.5 equals 0. Substitute everything, so you get ay equals 187.5 Newton. Okay, so now you already obtained all of the reaction forces. Then we can start the potong lah. Okay, we can potong at point C. So we need to redraw the free body diagram. So at point C we have NC, VC, and MC. And then at point A we have AY. And then here we have the 100 times 1.5. Okay, then from this free body diagram, repeat the process, ulang balik. So we can start with force in the x direction. So only have NC, so NC equals 0. And then force in the y direction. So here you have AY minus VC minus 100 times 1.5 equals 0. So guna calculator. So VC equals 37.5 Newton. And then lastly, to determine MC, we can take moment at point C. So here at point C, we have moment MC. And then AY times 1.5, it will be clockwise direction. So minus AY times 1.5. And then we have 100 times 1.5 times 0.5, 0.75. And this will act in counterclockwise. Okay, so plus 100 times 1.5 times 0.75. Okay, then guna calculator untuk kira. Okay, so kita dapat 168.75 Newton meter. Or counterclockwise. Okay. Any question? Okay, so I hope you understand the process. Kalau salah kira tu tak apalah, cuba lagi, okay. Tapi as long as you understand the process, salah kira tu kena siapkan tutorial lah. Nanti maybe next week hantar ke. Okay, so let's look at maybe
Sir,
question.
Encik Jamil,
Yes, yes saya.
boleh tak kita buat soalan nombor 5? Sebab soalan nombor 5 tu dia guna pound dan feet.
Oh,
Dia tak
Pak.
dia tak macam dia tak macam soalan lazim guna dia tak macam soalan biasa guna meter dan newton.
Kalau soalan macam ni, I akan suruh you tukar pound tu jadi Newton, feet jadi meter. It's just unit issue lah.
Oh,
Okay. Nak buat yang ni ke?
5 dan 6
tak-
boleh. Kita buat dua-dua.
Okay, boleh je. Okay, I try. Kita try nombor 5 dulu.
Okay, danke.
Okay. Okay, so question number 5. Determine the internal normal force, shear force and bending moment at point C in the beam. So here kita replace pound jadi Newton, feet jadi meter. Okay, because in your test and exam, I will give in Newton and meter lah. I will not give in pound and feet or any other weird weird metric system. Okay, I will give in SI unit lah. Okay, so here we have distributed load. So this is a square load, and then we have a rectangular load. Okay, so honestly I tak tahu nak buat, tapi kita cubalah. Okay, so here we can split the load into two. Okay, so we have 300 Newton per meter, and I think this will be 300 Newton per meter as well. If I'm wrong, if let's say you look at YouTube, I salah, I minta maaf lah ya. Okay, so let's say this is the square distributed load. So we can determine the resultant force first. So the resultant force will act in the middle or at point C. So it will be 300 times 6. Okay, the distance, the length, 3 plus 3. And then for the other distributed load, it will be it is a triangular distributed load. So for triangle, you need to remember this lah. Okay, so if you have triangle load, so if you want to convert the distributed load into resultant load, then it will act at this location. Okay, so it will be 1/3 of the length. And then the total, the resultant force will be, let's say F times length divided by half. Okay. So here it will act at this point. It will be 1 feet or 1 meter. So it will be 300 times 3 divided by half, divided by 2. And then at point A, you have reaction AY and reaction AX. And point B, it's a roller, so you only have BY. Okay, so we have all of the forces, then we can now draw the free body diagram. So we have AY and AX. And then we have BY here. So 6 meter. 3 meter, and then we have load here, so point C. So it's 300 times 6, and then we have another load here, 1/2 times 300 times 3. Okay, then we can start with the equation of equilibrium. So this is our free body diagram. So maybe we can start at point A, moment at point A. So moment at point A, firstly we look at the 300 times 6, the force 300 times 6. So this will be clockwise. So negative 300 times 6 times the distance 3 meter. And then the force By times 6 meter. So the direction will be clockwise, okay, counterclockwise. So plus By times 6. And then we have the third force 1/2 times 300 times 3 times 6 plus 1 meter. So it will be clockwise, okay. Okay, so that's all the moment at point A. Then we can determine By. So By equals 1425 Newton. Okay, and then we can do with force in the x direction. So in the x direction, you only have ax. So ax equals 0. And then we can do with force in the y direction. So here you have ay plus by minus 300 times 6 minus 1/2 times 300 times 3 equals 0. So you can get ay. So ay equals 825 Newton or pound, okay?
Sir, 300
Sorry.
times 6. 300 times 6 to 6 to conversion punya factor eh.
So dia adalah distributed load.
Oh, okay. Understand.
So times the
Understood.
length. Okay.
Okay. Ya, faham.
Tapi kalau I salah kira ni, you check YouTube lah.
Okay.
Okay, and then
Tapi sir, dalam exam you takkan bagi pound dengan feet kan? You akan stick to Newton dan meter. Okay.
Ya, betul. Betul. I tak bagi I akan bagi Newton meter. Newton and meter. Nah, kalau pound tu nanti you pening Lepas tu semua repeat lagi. I tak nak you repeat. Nanti I kena ajar lagi. Okay, so now you already found all of the reaction forces. Now we can potong at point C, okay? So if you potong at point C, you can draw the normal force C, the shear force C, and the moment at C. And then we have AY. And then we have distributed load just now, the 300 pound per feet. So if you cut here, so you only consider this force only, this portion of the distributed load. So it will become 300 times 3, okay? Because the length here is 3, okay? So 300 times 3 only. So in your free body diagram, you have a resultant force acting in the middle, 300 times 3. So the location is 1.5 meter from point A. So compared to the previous free body diagram, it is acting at point C, but now it's acting here in the middle, okay? Because you only consider this portion only, portion A until C only. Okay, so now you have the free body diagram. Then you can calculate all of the forces inside point C. So we can start with equilibrium in the X direction. So in the X direction, you only have NC. So NC equals 0. And then we can start with, we can do the force in the Y direction. So in the Y direction, you have AY. You have minus 300 times 3 because it's acting downward. And then you have VC also acting downward based on the drawing. So here you can calculate using AY from previous result. So you get VC equals negative 75 Newton. Okay, and then we can find moment at point C. So moment at point C, we have the moment itself, MC, counterclockwise. And then we have the 300 times 3, the force here, times the length, 1.5. So this force will be acting counterclockwise. Positive. And then another one is the AY. So AY times 3. So this will be acting clockwise. So negative AY times 3 equals 0. So calculate. So you get 1125 Newton meter or pound feet. Okay.
Ustaz,
Yeah.
yang VC tu dia tempat negatif. So dia punya direction dia ke atas ke macam mana? Dia memang ke
Sebenarnya dia ke atas lah. Tapi kita dah define dia ke bawah. So maksudnya dia ke atas lah. So if your answer is negative, it's okay as long as dalam gambar ni you define dia dekat mana. So contohnya you define dekat bawah sebagai sebagai you define VC ni sepatutnya acting ke bawah. Tapi now you get negative, meaning that VC ni sepatutnya bertindak ke atas lah. So if you draw VC, it's based on your free body diagram. If you draw free body diagram ni VC bertindak ke atas, then you should get positive. Faham tak?
Faham.
So kalau you dapat negatif sebab you lukis dia ke bawah, betul juga sebab sepatutnya dia bertindak ke atas. Macam tu. So in the end, jawapan you kalau you jawab negatif, I akan tengok free body diagram. Kalau free body diagram tak ada, dia tak tally lah jawapan tu. Maksudnya jawapan you tu kita tak boleh nak identify direction dia kat mana, atas ke bawah ke, sebab free body diagram tak ada. So kalau you ada free body diagram, you dapat negatif, kita tengok free body diagram, you tulis VC ke bawah. So betul lah, kita akan bagi betul. Tapi bila you lukis free body diagram VC ke bawah tapi jawapan positif, so kita tolaklah satu markah macam tu, tolak 10 markah ke, macam tu lah. So that's why free body diagram is important. So when you draw free body diagram, kita tahu you nak define direction of the forces kat mana. Okay. So kalau okay, kita proceed dengan tutorial soalan terakhir lah, soalan nombor 6. Okay, question number 6. So determine the internal normal force, shear force and bending moment at point C in the beam. So here we have pin support at A. So pin support kita boleh pecahkan jadi AY, AX. And then we have member BD. So BD ni dia sama je macam if you draw the straight macam ni, dia akan ada force yang sama. Maksudnya force sini dengan force ini adalah sama. Dia adalah shared members. Kalau kita ingat yang last week kita buat tu, dia adalah shared members. So you can choose either one. You can choose BD, you can choose D, or you can choose B. So in this case, maybe we can choose B lah, senang sikit. Okay, so let's say you draw a force here, FBD. Then you can you can split the force into X and Y component. So we have FBDX and we have FBDY. So how to split the force? You use cosine, sine and cosine. So maybe kita lukis lah sebab tak nampak. So this is FBD. FBD. So this is FBDY. FBDX. So kita kena ambil kira dia punya length here and also this length. So this is 3 meter, 3. So this is 4. So dia triangle yang 3, 4, 5 tu lah. So let's say you define this as theta. So FBDX equals FBD cos theta. So cos theta equals 4 over 5. So 4 over 5 FBD. And then FBDY it's FBD sine theta. So it's 3/5 FBD. Okay. And then the distributed load. So if you want to convert into resultant load, it will be acting in the middle. So 6 meter divided by 2, it will be 3 meter. So the resultant force is 5 times 6. Okay, the length of the beam, 6 meter. Okay, so I think that's all the information yang kita nak. Then we can draw the free body diagram to remove all of the unnecessary component in the question, so that we can analyze the beam only. Okay, so we draw the free body diagram. Apa tadi gambar dia, tak ingat. So we have the beam, and then AX, AY, and we have point C, we have point B, so we have F, B, D, Y, F, B, D, X. And then find 5 times 6. So this is 2 meter. And then we have this point, 5 times 6. FBDY, FBDX. Okay. So we can start with finding moment at A. Okay, so we have 5 times 6, the force 5 times 6 times the length 3. Okay, so 5 times 6 times length. So this is clockwise. So negative 5 times 6 times 3. And then we have the force FBDY. So from previous derivation, FBDY equals 3/5 FBD. Okay, so 3/5 FBD, FBDX, 4/5 FBD. Okay, so FBDY times the length 4 meter, and it will be acting counterclockwise, so positive 3/5 FBD.
Sir, saya ada satu
times 4.
soalan.
Yeah.
Kenapa ada force kat BD tu sebab kan support dia L shape. Dia tak ada macam kalau support dia L shape kan sepatutnya force dia vertical dan horizontal. Like vertical saja.
Yeah, I know what you mean lah.
Like
Dia akan ada force ini.
if it's bukan. If it's L shape kan, dia akan ada satu force yang sama dekat DX dan BY saja, bukan ke? Like
Sebab
vertical
dia
at BY and then horizontal kat DX. Lepas tu dua value dia sama.
Masuk ke you macam ni lah, DX sini, DY sini. So sini BX and BY kan.
Ya.
Hmm.
Kenapa ada
Okay, so
macam yang slanting FBD tu
it's literally the same thing lah. If you imagine macam mana nak cakap, the only difference is when you cut the structure. When you cut the structure at this component, right, then you can see the internal loading different. Okay, but now it is tak cut lah, dia tak potong kan. So dia punya force tu in terms of vector, magnitude dengan direction, it will act some similar to the slanted version. Faham tak macam mana nak cakap
ada sedikit confused.
I tahu.
Sebab understanding saya, kalau dia ada FBD kan, dia sepatutnya ada satu batang yang support dari D ke B, yang slanting tu.
I tahu you nak cakap dia patutnya macam ni kan.
Ya.
Yes. It's the same thing here.
Kenapa question dia bagi L
It's the same thing. Cuma the difference is the internal load dia lain. Macam mana cakap, dia punya force vectors are the same.
Also dia akan result in the same force in the components, same direction lah untuk dua shape ni.
Betul. The difference between the two is only inside the material, in terms of stress in the material, in terms of internal load. That's the difference. But the resultant force, dia akan
result in the same
this
direction.
Betul. Okay. So harap faham. Okay, now you already have this equation for moment at A. Then we can find FBD. Okay, so 5 times 6 times 3 divided by 4 divided by 3 times 5. Okay, so you dapat 37.5 kilonewton. Okay, so here you can convert the real value lah, 37.5 times 3 divided by 5. Okay, and then we can do the force in the in the x direction. So force in the x. So we have AX, and then we have FBDX. So AX equals minus FBDX. So we have negative 30 kilonewton for AX. And then force in the y direction. So we have AY plus FB dy minus 5 times 6 equals 0. Then we have we can substitute and calculate. So AY equals 7.5 kilonewton. Okay. Then from here you can now you can cut at point C. So at point C you have NC, VC, and MC. So we have AX here, AY here, AX here. And then we have distributed load 5 times 6. So now you cut at point C. So it will become 5 times 2. Okay. And acting in the middle. So 5 times 2. Acting in the middle. Okay, so repeat the process. So force in the X direction equals 0. So we have NC plus AX equals 0. So NC equals 30 kilonewton. Okay. And then we have force in the Y direction. So we have AY plus minus BC, sorry. Minus BC minus 5 times 2 equals 0. So we have VC equals 2.5 kilonewton and negative, sorry. And then moment in at C. So at C we have MC, and then we have AY times the length 2 meter, and this is clockwise. So minus AY times 2. And then we have 5 times 2 times 1. So this is counterclockwise. So plus 10 times 1. So we get MC equals 5 kilonewton meter. Okay. Any question before we proceed with our lecture?
Sir, so nak tanya lah, untuk support yang shape L dan shape bending rod tu, kita hanya ambil satu point saja X dan Y kan?
Yang tadi betul.
Sebab so kalau let's say lah dia ada macam support bentuk L ataupun slanted rod kan yang you lukis tu, dua-dua shape tu dia akan ada macam slanted FBD punya force, FBDX, FBDY lah. Lepas tu kita hanya ambil satu point saja kan. Kita tak payah ambil dua-dua. Oh, okay. Semasa kita analisis, kita ambil satu point saja yang senang, yang ada kat itu yang ada on acting on
dekat
itu
beam.
punya.
Betul.
Oh, okay. Faham.
Okay. So try to do all the tutorial yang this page 1 punya. And then maybe next week hantar lah page 1. Okay, page 1 ada 6 soalan je. Okay, kita dah discuss 4. So you can do the other 2, okay? Or if you rasa jawapan I salah, you can search in YouTube, okay? There are answer in the YouTube. So this the page number 2 maybe the following week lah, okay? Nanti kita fikirkan. Okay, so now we can proceed with sorry.
So nanti you akan send yang annotated version file ni kat WhatsApp tak?
Tengok dulu sebab I dah macam dia dah lari-lari dah ni. Alamak, I pun tak tahu apa jadi.
Oh, okay.
Tak apa, I akan post video dalam YouTube. Nanti I bagi link YouTube video. Okay, so what we learned from last week and until this week is about finding reaction forces and finding internal forces. Okay, so basically macam sort of like revision of statistics lah, which is okay because throughout the course until the end of this course you will do the same thing. Okay, you need to determine the reaction force, you need to determine the internal loading before you determine the stress and strain inside the structure. Okay, so we continue with our lecture that we stopped last week. So from last week we stopped at analysis the internal loading of the structure. So why we need to determine the internal load of the structure is because we want to determine the stress and the strain in the structure. So today we will cover the concept of stress, what is stress, and then maybe show you 1 or 2 example from tutorial, okay, or from the slide. Okay, so stress is a measure of the internal force per unit area. So you know from maybe you have learned before during A level or during matriculation, during diploma. So stress is just force over area. Okay, but there are a lot of definition of stress that we will cover today. What sort of area we want to use, what sort of force we want to use to determine the stress. Okay, so it's the internal force per unit area within a material that is caused by external forces. So we have 2 types of stress. We have normal stress and also shear stress. So later on we will see what is normal and what is shear stress. So normal stress first. So the resultant of the internal forces for an axially loaded member is normal to a section cut perpendicular. So normal meaning that the force acting normally perpendicular direction from the surface area. Okay, so if you have surface area, let's say surface area shown here. So if the force acting perpendicularly from the area, then the normal stress is simply force divided by area. Okay, so that's the meaning of normal stress. So the force intensity, so if you have the force acting on the section, is defined as normal stress. So normal stress is basically the total force divided by area. Okay, so ada limit tapi tak pakai lah formula limit. Okay, so we defined it as an average. Okay, in terms of average normal stress. So average normal stress is simply the force or the force P divided by area. So the normal stress at the particular point may not be equal to the average stress, but the resultant of the stress distribution must satisfy. Okay, so apa yang nak cuba sampaikan ialah if you have a force here P, but if you look at how the force or the stress distributed on the structure or on the surface, it will not be like so let's say if you have a square structure, So if you have a force, so let's say a force P, so the stress is not distributed equally. Okay, the stress is not distributed equally on the surface, so it will distributed maybe curve shape ke, maybe triangle shape ke, for example. So the stress that you are finding in this lecture is basically the average stress. Okay, dia adalah stress yang average. Okay, you tak determine the stress at one particular point lah. You determine the average stress on that surface. Sebab dia punya formula basically you have integration dy dx and so on, but for the sake of understanding throughout the course, you are finding the stress, we call it average stress. Okay, so the detailed distribution of the stress is indeterminate, susah nak dicari lah. Usually people will use software like maybe you have learned in CAD modeling, finite element analysis. In CAD modeling, maybe if you have done a finite element analysis in CAD modeling, basically we use software to determine the actual distribution of the stress on the surface. But for calculation, manual calculation, you only determine the average stress. So again, here we show you the force. It is actually distributed, but the stress you are finding is just average. So there are two types of normal stress. We have tensile stress, meaning that stress yang menyebabkan the structure is being extended, tertarik. It's like tarik or extended. For compressive stress, it's a stress that making the structure to be compressed. Okay, so we have two types of normal stress. We have tensile and also compressive stress. So usually we have sign convention for stress. So stress also have direction similar to force. Okay, so for normal stress we use positive to represent tensile and negative to represent compressive stress. And in SI unit, the stress unit is Pascal, okay? Or force per unit area, Newton per meter squared. But usually when you answer your question, you write the unit in Pascal instead of Newton per meter squared. Okay, so remember Pascal and Newton meter square. So let's look at an example. So we have this structure, I think from last week punya structure lah. So can the structure safely support 30 kilonewton load? So let's say you have 30 kilonewton load here. So let's say you apply the 30 kilonewton load. Will this structure remain static or will it move? Okay, given the dimension of the beam, just 50 millimeter thick and 800 millimeter length, and you have the diameter of the rod 20 millimeter. So from static analysis from last week, we determined that FAB, this force, FAB, and this force, FBC, it's 40 kilonewton compressive for FAB, and then extension for FBC, so meaning that it's the other way around. Okay, so FBC tension, FAB compress. Okay, so before that you need to look at the direction of the force. So when it says compress, meaning that FAB is acting in this direction, going to the positive X. Then FBA at this point B here, it will directed towards A. So if you imagine there are two forces acting at point A and point B, pushing the structure so that it is compressed. Okay, so at structure BC. So it is tension, meaning that one force at point B is going away. At point C also going upwards, okay, going away lah, away from the structure. If you imagine, it is like pulling this the structure or causing extension or tension into the structure. Okay, then at any section through member BC, so at any point on the BC, so you need to determine the area to determine the stress in the structure. So we know that the stress is just force over area. So you determine the area of the cross section. Okay, so let's say you take cross section here. So it's simply a circle. Okay, circle with diameter 20 millimeter. So the area will be just pi r squared. Okay, so pi 20 divided by 2 millimeter. It's times 10 power of 3 squared. Okay, so that's why you get this answer here. Okay, so you need to imagine. I'm sorry, yes.
Nak tanya macam mana kita tahu FAB tu 40 kN?
Ni from previous week punya, from previous slides, last week punya.
Oh.
Dia dah yang kita kira last week tu.
Lepas tu macam mana kita tahu dia compression
semua dari last week juga.
Oh, okay. No
kena
wonder
refer
lah saya macam confused dengan statement dia. Like straight away jump to FAB equals 40 kN.
Faham. It's actually we have do this from previous week lah, from last week. So maybe you can refer the previous slides. They basically they skip analysis tu sebab dah buat last week. Okay. So you calculate the area. So you get pi times 20 divided by 2 times 10 power of minus 3 squared. Okay. So for me, if you want to calculate the area, when you find the unit in millimeter, it is best to convert it into meter first. Okay, always convert it into meter, then you square the value. Okay, do not use in millimeter because it will confuse you later during your calculation. So always convert every unit into the SI unit. Okay, so in meter, in Newton, in kg, in anything else lah. Jangan letak dalam millimeter lah, dalam kilonewton. Okay, make sure you convert it into meter and also Newton. Okay, so that you tak buat salah dalam pengiraan. So here in the example, so P is simply 50 kilonewton. So they convert dalam Newton divided by area. Okay, so they convert dalam meter. So now you can get the answer in terms of Pascal. So if you don't want to convert into megapascal, that's fine. Okay, so let's say you dapat answer 159,000,000 something lah kan. You tak nak convert dalam megapascal, that's fine, totally fine. It's just that you need to make sure that during your calculation, you write it in meter and also in Newton and also in meter. Make sure you convert it first before you find the final answer. Okay. And then for the second one, let's say you are given the material of the rod. It is made of steel, for example, steel. So let's say for steel, you are given that the allowable stress for steel is 165 megapascal. Okay, let's say you are given. Okay, yang ni given. Okay, so you compare your calculation with the properties of the material. So you compare with the properties of the material. So from your calculation, you get stress 159 megapascal, but the material can withstand up to 165 megapascal, meaning that the force 30 kilonewton here is adequate. Okay, is the structure is adequate enough or strong enough to cover the force 30 kilonewton applied on the structure. Okay, but that is for the rod. Okay, so let's say you are required to design something, okay, to design a new structure, for example. Okay, so design of new structures requires selection of appropriate materials and component dimension to meet performance requirement. So for reasons based on cost, weight, availability, blah 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 blah, so you choose to use rod made from aluminium. So now aluminium has only 100 megapascal. So obviously the diameter given here is not going to support the force 30 kilonewton, because from previous slide we know that the stress from previous slide we know that the total stress is 159 megapascal. But let's say if you want to use aluminium because it's cheaper, but aluminium can only sustain 100 megapascal. So you need to redesign. Okay, you need to redesign the structure by changing the area, changing the diameter of the rod. So the calculation is the other way around. Instead of you finding stress, but now you are finding the area of the rod. Okay, so you are given the force from previous slide, 50 kilonewton, and then the stress that the material can sustain, which is aluminium, 100 megapascal. Okay, so this is the stress from aluminium. So you get the area of the rod, the cross sectional area of the rod should be 500 times 10 power of negative 6 meters squared. Okay, so rod is a circle, so you need to use pi d squared divided by 4, okay, to determine the diameter. So now here you can you calculate the diameter, you get 25.2 millimeter. So meaning that you need a bigger diameter of the rod if you are using aluminium. So you can take the diameter bigger than 25.2. So here, for example, you take 26. So if you take 26, then the rod can sustain the force given if you are using aluminium. Okay, so maybe this kind of question will not come out in your test, but maybe in other subject, maybe starting next semester for first years, you will take maybe MEC, mechanical and electronics components, something like that. You will need to understand how to design a structure by calculating the stress and so on. But for other seniors like second years and third years, maybe you going to use this in your final project or in your subject product development. Okay, you will use a lot of this kind of analysis to determine what sort of size or dimension of the component that you are going to use on your prototype and so on. Okay, just now it's about normal stress. So here we also have shearing stress, okay, shear stress. So like last week when I explained to you what is shear, it's basically like sort of like a friction lah, okay. So if you have your hand with you, I know you have hands, so you clap your hand and then you can macam gesek-gesek dia, okay. So gesek-gesek tu is the shearing, okay, shearing between both of your hands, okay. So here is an example. So you have forces P and P prime are applied transversely on the member AB. So when you have force P and force P prime, and then if you cross the structure at point C, so dia ada shear, okay, ada shear dekat dalam structure dekat point C tu. Or in our tutorial just now is the force VC lah. The force VC is the shear force in the internally in the structure. So corresponding internal force act in the plane of section C are called the shearing force. Okay, so force inside the C applied on the plane. So let's say you have a plane, permukaan. So the force acting, okay, on the instead of perpendicular, now it's parallel to the plane surface. So we call this as the shearing force. Okay. So the resultant of the internal shear force distribution is defined as the shear of the section and is equal to the load P. Now we want to find the shear stress. So shear stress, similar to normal stress, it is also defined in terms of average shear stress. So the shear force divided by area. So now you have two things to remember. Let's say you are the permukaan, let's say surface A. So if you have force acting going out, let's say force perpendicular force, and then you have another force in parallel. So force parallel. So normal stress, we use the symbol sigma. Normal stress is simply force perpendicular divided by the area, surface area. And then if you have shear stress, so we use symbol tau for shear stress. Tau is just the force parallel divided by the same area. Okay, so the area are the same. Okay, so shear stress distribution varies from 0 at the member surface to maximum value. So similar, dia bukan similar throughout the surface. Dia ada distribution. So we cannot determine the distribution by simple calculation. But we can determine it using finite element analysis. Okay. Okay, kita tengok example. So let's say you have this bolt and nut yang pasang pada kayu lah. So let's say you ada kayu A and kayu B. Okay, so kayu A, kayu B ni permukaan A and permukaan B, the surface of A and the surface of B, it is only in contact at one surface only. Okay, ni satu surface saja, one only. But in the figure on the right, you have two surface in contact. Okay, for structure A and B, two surface contact. Okay, so for shear, if you have one area in contact, you only divided by one area. But if you have two area in contact, you divide by two. Okay?
Sir, at the bottom of C, there is also shear force, right? Bottom of C and the top of D.
This one, is it? This?
No.
This figure.
Just below the C, the plate.
This one ke?
Sini tak ada shear force ke?
Ada, tapi itu calculation dia lain. Yang kita nak kira ni yang kat sini. Ni nanti ni calculation dia is based on the area of the nut lah, of the circle. But now we are focusing on this. Okay. So it is based on the question lah. If the question asks you to determine shear at A and B, then it is this surface lah. If the question asks you A and C, then it is this surface. Okay. So if you have double shear like B, C and D, then you divide it by 2. Okay. So there are other stress like bearing stress and so on, but this is not going to come out in test or any lectures after this lah. But this is just some knowledge for you lah. Okay, so let's say if you have this circular surface here, bentuk bulat kan, bentuk silinder. So you have what we call bearing stress because the surface is um, uh, or we call it bearing surface. The surface in a bearing shapes code. Okay, so it's the same thing, but you need to find the area, contact area between the shape A and the bolt and nut. So for example here, the contact area here with the contact area here. Okay. Tapi ni tak keluar test lah, tak ada test pun. Just beritahu je, mungkin boleh buat tutorial seterusnya. Okay, this is a continuation from previous example tadi yang 40 kilonewton and 50 kilonewton tadi. Okay, this skip sikit. So would like to determine the stresses in the members and connection of the structure. So sekarang ni now we want to determine the stress at the support pula, okay, at this pin and also this pin. So from static analysis, we determine FAB 40 kilonewton and FBC 50 kilonewton compression and tension. And then we must consider maximum normal stress in AB and BC and the shearing stress and bearing stress at each connection. So we look at the rod first. So the rod is in tension with an axial force 50 kilonewton. So at the rod center, the average normal stress in the circular cross section is 159 based on previous calculation. So at the flattened rod ends, dekat sini, the smallest cross section area occur at the pin center line. Ni apa dia cakap apa dah. So it is happening here, okay. So at this point here, yang I potong ni, it has the smallest contact area, okay. Okay, so the smallest contact area of the structure with the pin is at the center line, okay. Dia yang paling kecil sekali yang ada contact, okay. So dia kira dia dapat the stress, the stress at this point is 167. So the boom is in compression with an axial force of 40 kN and average normal stress -26. Mana dapat dah. Tak apa, ni tak keluar. The minimum area sections at the boom ends are unstressed since the boom is in compression. Kita skip. Okay, now the cross section, the pin shearing stress pula dekat pin. So meaning that at this between the pin here. So you need to determine the area of the pin, the contact area. So the diameter is this one, the 25 millimeter. So determine the area. And then the force on the pin at C is equal to the force exerted by the rod BC, which is just now is 50 kilonewton. So just now it's the near normal stress, but now it's the shear stress at this point. Okay, so it's just the force divided by area of the rod or of the pin. Okay. So the pin at A is in double shear. Okay. So ni kita boleh tengok previous slide lah. Sekejap. So here at point A here, this you have double shear, okay? One here and then one here. For the beam lah, it is in contact with the top part and the bottom part. But for the rod, you have only one contact area. So nanti maybe I will give you some maybe if you look at the tutorial later, or maybe I will give you one example question ke, we will see how you need to look at the structure, how many contact area yang that structure has. Okay, so if you have two contact area, then you need to divide it by 2 and so on. So for the pin at point A, you have two contact area, one at the top and one at the bottom for this beam. So because you have two contact area, then they exerted double shear. So it's supposed to be 40 kilonewton divided by area. But because you have two contact area, so you divided by 2, okay? So dia jadi 20 kilonewton. So instead of 40, because of 40 divided by 2. Okay, so yang confused lah kenapa 20, because it's already divided by 2, okay? Okay, so now it's the shearing stress. Tak adalah, I tak tanya benda ni dalam in your exam. It's just additional info lah. So this is how you determine bearing stress. So you need to determine the thickness of the rod, then just multiply by diameter. Okay, ini example apa? Ya, I tengok dulu. Okay, okay, so let's look at this example. So let's say if you have a lamp, 80 kg, and this lamp is supported by two rods, AB and BC. So you have rod AB and rod BC. So they are rod, okay? So rod is cylinders lah. As shown in the figure. So if AB has diameter 10 millimeter, so this is 10 millimeter, and you have BC 8 millimeter. So determine the average stress in each rod. Okay. So as I said in mechanics of material, in MOM, before you can determine the stress, you need to do static analysis. Okay. So first you draw free body diagram. So this is free body diagram. You draw the force FBA and FBC, and then the force, the weight of the lamp. Okay. So determine FBA and FBC using equilibrium equation. So first determine the axial force, okay, or the rod, the force on the rod, okay. So we take the force in the x direction. So FBC cosine, so you get 4/5 times FBC. So FBA cosine 60, it will act in the negative direction. So you minus FBA cos 60. And then repeat the process for y direction. You get FBC 3/5 times FBA sine 60 degree minus the weight. Okay, weight. Okay, now you get simultaneous equation. So you can solve a simultaneous equation either using your calculator or manually, up to you. Okay. So I dah post dalam group macam nak solve pakai matrix using calculator. You can do that or you can solve manually, up to you. as long as you get the answer correctly. Okay. So now using based on the example, if you use Newton's third law of action, equal but opposite reaction, these forces subject the rod to tension throughout their length. So you get positive for both force, FBC and FBA. So meaning that here the force will act upward, similar to force in AB. So meaning that it causes tension in the rod. Okay. So if you don't know whether it can cause tension or compression, you need to maybe imagine how the the behavior of the structure lah. Okay, so let's say if you look at this figure, so lampu ni dia berat ke bawah. Okay, so berat dia ke bawah, dia akan menyebabkan the rod is being ditarik. Okay, the rod is ditarik ke bawah. Okay, meaning that akan ada force yang tarik dia ke atas. Okay, so the force FAB and FBC, CB or BC akan menyebabkan the rod is being pulled. Okay, dia ditarik. Okay, meaning that rod tu akan ditarik lah. Okay, or akan memanjang ataupun ada tension. Okay, ada tension on the rod. Okay, later on you mungkin akan confused lah. Okay, kita tahu force tu kat sini, so you might think that kalau force ni kat sini bertindak ke atas, then the force on CB will be this direction, so it looks like compressive force, but they are not compressed. Okay, they are extend. Okay, so they are tension force. Okay, so I punya cara, I imagine dia pergi kat mana. Okay, so lem ni berat, dia akan tarik ke bawah, dia akan menyebabkan rod tu in tension. Okay, akan memanjang. Okay, so both force FBA and FBC are will create tension or tensile stress. Okay, so to determine the average normal stress, so first normal stress BC is simply force BC divided by area of the rod. Okay, so the first rod BC is 8 millimeter diameter, so you need to determine the area first. Okay, 8 millimeter diameter divided by 2, you get a radius. Okay, ataupun guna formula pi r squared. Okay, so convert the millimeter into meter. Okay, millimeter equals 10 power of 3 meter. Okay, must convert first before you calculate with power of 2. Okay, so you calculate, you get 7.86 megapascal for stress in BC. Similar for BA, convert the diameter in meter. Okay, so 10 meter equals 10 times 10 power of 3 meter. So convert in meter, and then baru you kira berapa stress. So you dapat 8.05 megapascal. So if your answer is positive, meaning that it's a tension. If it is compression, then you put negative lah. Okay, but now you don't have the unit, I mean the sign negative, meaning that both of them are in tension. Okay, let's look at another example. So determine the average shear stress in the 20 millimeter diameter pin at point A and the 30 millimeter diameter pin at point B. So point B, dia lukis macam ni. Okay, dia tunjuk macam ni. So meaning that there is only one shearing stress because there is only one surface contact. Okay, But at point A, you have two surface contact here. Okay, so firstly, you need to determine the reaction forces at point A and point B. So this is the free body diagram. Okay, so at point A, you have AY and AX. At point B, you can use the force member relationship. So FBC and FCB are the same. Okay, so you use FB. So you tak perlu ambil C lah. Okay, you draw the free body diagram. So from here you can determine the forces by using equilibrium of moment and equilibrium of forces. Okay, cara kira dia nanti kita tengok lebih detail next week lah. Okay, so you get FB, you get FB, AX and AY. Okay.
Sir, so at B there is a shear force, right? Tapi susah lah nak notice.
Dia akan give you the figure. Usually they will give you figure. Like
They
this
will
one.
zoom in lah.
Ya, betul.
Oh, okay.
Dia takkan bagi you, dia akan bagi you gambar detail lah. Okay. Okay, so now you already have FB, AX and AY. So you want to determine the force, the shear stress at point A. So because point A you have AX and AY, so you need to determine the resultant force. Okay, resultant force at point A. So if you look at this drawing here, need dia lebih detail lah. Okay, the point A is actually the force. You have two component, tapi the resultant force is slightly slanted lah. Okay. So the pin at A is supported by two fixed leaves. Ada dua contact surface. And so the free body diagram of the center segment of the pin shown in figure has two shearing surface. Ada dua shearing surface. Okay. So each surface, untuk determine the shear of one surface, you divide it by 2. Okay. So we call this case double shear. Okay, so force FA divided by 2 to get only one force lah, one component of the force VA. Then from there you divide it by area of the circle of the rod of the pin. Okay. So similar to FB, the tali here, the B here, but it's only have one contact surface, so you divide by one area lah, one area only.
So sir, kalau question tu cakap shear stress, maksudnya kita kena cari stress kat itu, support itu. Kalau dia cakap normal stress tu normally kat body tu kan.
Tapi normally like that lah. Okay. Tapi nanti after midterm kot, we will learn more about shear stress. Like for example, if you cut the structure in the middle, so when you cut in the middle, you have NC, VC, and MC, right? So NC will result in normal force and normal stress, but VC will result in shear. Okay, so later on after midterm, we will learn more about shear stress. When you cut the structure, then there will be a shear, okay? Shear stress due to VC, okay? As what we did in the tutorial just now, VC will result in shear, and C will result in normal stress, okay?
So dia more complex version of tutorial yang kita buat tadi lah. Dia akan involve normal stress dan shear stress. Okay.
Betul. And itulah dia complicated nanti. Dia akan complicated. A lot of calculations lah. But we will look one by one lah. Maybe after this we will look at only normal stress on rod only rod. And then after that we look at sorry.
Untuk tutorial tadi kita hanya cari NC dan VC saja kan, MC. Kita tak payah cari stress of VC, stress of NC tu.
Betul. Yang tu tak perlu cari stress lagi sebab to determine stress we need to understand the surface area. We need to know the surface area, and there are other things that you need to understand like moment of inertia, and then you need to kena tahu a lot of things lah that will be discussed in later lectures, later chapters. Okay, but for now you only need to know about stress at the pin support, maybe in the beam in general. Okay, pukul berapa dah? 12. Okay, I think we can stop here. Okay, we can stop here. And maybe you can continue do your tutorial for the second page. Okay, try look for the answer in YouTube. If you find that some of the tutorial requires calculation yang tak belajar lagi, you can skip. Okay, you can skip, or you let me know in advance lah, so that I know yang ni alamak yang ni salah bagi soalan contoh lah. Okay, so I think
so yang
okay, yes,
yang lecture example 5 tu kita continue next week.
yes, good.
Okay,
hopefully. So we have lecture 5. This slide je. And then actually I want to teach next week. I want to teach about axial load. Okay, because strain is also important, but not so important lah. Okay, maybe we can go to axial load, and then we can do test 1 in week 5. Macam tu. So we are now week 4. So last week kita agree nak buat test week 5 on 5th of April.
so dua test kan, satu kat 5th of April, lepas tu satu kat 25th
Satu on the fall after cuti.
Oh, okay.
So I plan test 1 axial load, test 2 torsional load.
Kita sudah belajar ke yang 2 chapter ni?
Belum. Nanti kita ajar next week.
Okay. Okay.
Sekejap je axial load. Strain ni penting juga, tapi strain ni is just about length divided by original length, which is tak adalah important lah juga.
So lecture 3 dan lecture 4 boleh kita ignore lah, ataupun dia akan repeat dalam lecture 5 dan 6?
Lecture 4 ni rasanya boleh ignore. Lecture 3 I need to check lah. I think can be ignored as well. Tapi but I will put tutorial lah later.
Okay.
But the crucial part is starting lecture 5, 6, 7, 8, 9, 10. The sixth lecture at the end here will use everything that you have learned in lecture 2. Static analysis, internal loads. Dia akan pakai kat sini lecture 5, lecture 6, lecture 7, 8, 9, 10.
But sir, sekarang kita hanya kat lecture 2 kan? Oh.
Betul. Lecture
So next week kita
3
akan
pergi lecture 5.
Oh, okay. So lecture 3 dan lecture 4 kita skip sajalah.
Kita skip. Maybe I ajar, ada masa I ajar lah. Tapi dia takkan affect lecture lain. Kalau tak ajar pun dia takkan affect lecture 6, 7, 8, 9 takkan affect lah. Lecture 5, 6, 7, 8, 9, 10 the most important lecture coming from lecture 2. So if you know lecture 2, you can do lecture 5, 6, 7, 8, 9, 10. So lecture 3 is important but not so important. Okay. That's it for today's class. Please do tutorial page 2. Then we can discuss lecture 2, tutorial number 2 next week. Okay. I think some of the questions maybe yang you tak belajar lagi. Okay. So maybe you can do question F17 first. And then if you understand, then you can proceed with the other questions lah. Okay. So that's it for today's class. Any question before before we end the lecture?
Doctor, what about the attendance, doctor?
Attendance tu kita nantilah, kita baik sangat, kita bagi je semua datang. Kita tanda je semua hadir. Alamak, tak boleh rakam lah benda ni. Okay, kita discuss di luar topik.